Here we're asked to prove that the limit as x approaches 0 from the left of x squared cosine 1 over x equals 0. Now for this proof, I'm going to use what's called the squeezing theorem. So I'm going to try to build this argument here up and then pass a limit and try to squeeze it between two numbers here. So we're going to start with cosine 1 over x. Now, no matter what x is, cosine is always a value between 1 and -1. Okay, that's an absolute fact. Now, what I'm going to do next is multiply through by x squared. Now, x squared is always a positive number, so this inequality will always stay less than. Right? So then I have negative x squared is less than or equal to x squared cosine 1 over x, which is going to be less than or equal to x squared. Okay, then at this point, I'm going to pass a limit. So we'll take the limit as x approaches 0 from the left or we'll pass that through this inequality. Okay, and that gives us this. Limit as x approaches 0 from the left less than or equal to the limit as x approaches 0 from the left of x squared. All right, so I passed the limit. Now it's this limit in the middle that we want. The limits on the ends we know because here, coming in from the left, it doesn't really matter. When I do the direct substitution, this is a polynomial. Plugging in x is 0, 0 squared is 0, so that limit is going to be 0. And this is what we're looking for. Less than or equal to. Now the limit on the right side, when I substitute, I also get 0 squared, which is also 0. So what I have here is a quantity that's greater than or equal to 0 and also less than or equal to 0. Okay, it's effectively squeezed. That means that quantity has to be 0 itself. So the limit as x approaches 0 from the left of x squared cosine 1 over x, it's been proved by the squeezing theorem that that actually equals 0. Now, just as a quick verification, I'm over here at DESMOS.com, and I'm going to look at that function x squared cosine 1 over x. To kind of verify my answer here, you can see here's the picture. Looks kind of neat. But as x comes in to 0 from the left, you can see that the limit, the y value is going to 0. So it's actually the limit from the right is 0 as well. So there's a sort of a visual to see that we did get the correct answer.